Hello students, welcome to my channel Engineering Education. For engineering related video and for problem solution, please subscribe my channel so that you can get notification for the upcoming videos. In this video, solution of problem 12.3 has been given, that is about positive displacement machines. The statement of problem 12.3 is a single stage single acting air compressor running at 1000 revolution per minute delivers air at 25 bar. For this purpose, the induction and free air conditions can be taken as 1.013 bar and 15 degrees C, and the free air delivery is 0.25 cubic meter per minute. The clearance volume is 3% of the swept volume, and the stroke to bore ratio is 1.2 by 1. We have to calculate the bore and stroke, the volumetric efficiency, indicated power, isothermal efficiency, and take the index of compression and re-expansion as 1.3. So first of all, we have to highlight that what is given in the statement. Given data is basically speed of the air compressor, that is N, and it is equal to 1000 revolution per minute. Also, delivery pressure is 25 bar. Delivery pressure is actually P2, that is 25 bar. Also, initial pressure is 1.013 bar, that is P1, 1.013 bar, and temperature, initial temperature T1 is 15 degrees C. The free air delivery is 0.25 cubic meter per minute. Clearance volume is 3% of the swept volume, that is clearance volume is VC. Basically it is equal to 3%, 0.03 of the swept volume Vs. Swept volume is represented by Vs while clearance volume is represented by Vc, and the stroke to bore ratio is 1.2 by 1. Also, we have to assume index of compression and re-expansion, that is N, and it is equal to 1.3. So this is the PV diagram, pressure and volume diagram. This is actually P1 and this is P2. P1 is 1.013 bar and P2 is 25 bar. These are the processes, compression and re-expansion processes. So this is the clearance volume VC. This small volume is basically the clearance volume, and this is swept volume represented by Vs. This is Vc, and while this is Vs. So From the problem, we have to find what things are required. Basically, we have to find first bore and stroke given above, bore and stroke of the compressor. Bore is basically the dia of the cylinder, and stroke is. Second, we have to find volumetric efficiency. The volumetric efficiency. So we have to find volumetric efficiency. Third, we have to find the indicated power. Also, number 4, we have to find the isothermal efficiency. So 4 things are required: bore and stroke, volumetric efficiency, indicated power, and isothermal efficiency. So from the given information and considering the air compressors given in the statement, swept volume of the cylinder is basically given by pi by 4 b square into s. We are actually going to find the bore and stroke. For that, this expression will be helpful. For example, this is expression 1. So also we have stroke to bore ratio, that is 1.2 by 1. So S will be equal to 1.2 B. So putting this in expression 1, Vs will become pi by 4 B cube into 1.2. So this is, suppose, expression number 2. Here we have to first find the swept volume. For that, from the given data and from PV diagram, swept volume is basically equal to VA minus VC. Also we have that VC is equal to 3% of swept volume, that is 0.03 of the swept volume. Also we have, from this expression, we have VA is equal to VS plus VC. So VA will become equal to VS plus 0.03 of VS. Actually, VS is replaced by 0.03 VS. So VA will become equal to 1.03 into Vs. Now, second, the volume induced per cycle can be found from the expression, that is VA minus VD, which is basically nothing but the ratio of V dot and N, where V dot is the free air delivery and N is the RPM of the compressor. So from this, VA minus VD comes equal to 0.25 divided by 1000. So it becomes equal to 0.25 into 10 raised to power minus 3 cubic meter. Also, we have an expression, that is VD equal to VC into P2 by P1 power 1 over N. So putting the values, VD will become equal to 0.03 Vs into 25 by 1.013 1 over 1.3. So by simplifying this, we get the value of VD, that is 0.3533 into Vs. So now it's very easy to put the value of VA and VD, that is volume induced per cycle, VA minus VD equal to, VA is basically 1.03 into Vs minus, and VD is 0.3533 into Vs. VA minus VD is basically equal to 0.25 into 10 raised to power minus 3, and it is further equal to 0.6767 of Vs. So to find the value of Vs, we will divide 0.25 into 10 raised to power minus 3 divided by 0.6767. So from this we get the value of Vs, that is 0.3694 into 10 raised to power minus 3 cubic meter per cycle. Now suppose this value is 3. So putting 3 in expression number 2, we get, also rearranging expression number 2. Expression number 2 becomes pi by 4 into 1.2 b cube, which is equal to 0.3694 into 10 raised to power minus 3. So solving it for b, B comes equal to 0.0732 meter, while in millimeter it becomes equal to 73.2 millimeter. So the value of bore is 73.2 millimeter. 73.2 millimeter. Also, we have stroke equal to 1.2 times B. So stroke is 1.5 times of B, 73.2. So multiplying 1.2 we get 87.84 millimeter. So the value of S is equal to 87.84 millimeter. So part 1 has been solved. Part 1 was started from here, in which bore and stroke were required. We found those values. Now second we have to find volumetric efficiency. So for that we have expression that is VA minus VD divided by swift volume. We know the value of VA minus VD, that is 0.25 into 10 raised to power minus 3 divided by swift volume, that is 0.3694 into 10 raised to power minus 3. So simplifying this, we get volumetric efficiency equals to 0.6767, which is 67.67%. Also, third, we have to find the value of indicated power. So for that, the expression of indicated power is basically N over N minus 1 P1 V dot into P2 by P1 power N minus 1 by N minus 1. We have the value of N, that is 1.3, P1 is 1.013 bar, V dot is 0.25 cubic meter per minute. So all values are known. Putting the values 1.3 over 1.3 minus 1 into 1.013, converting bar into Pascal. Also V dot is 0.25 into P2 is 25 and P1 is 1.013. 1.3 minus 1 over 1.3 minus 1. So simplifying these values, indicated power is 2000 watt, while in kilowatt indicated power is 2 kilowatt. Also, number 4, we have to find the value of isothermal efficiency. So for that we have expression, that is isothermal efficiency is equal to isothermal power divided by indicated power. So indicated power is known, that is 2 kilowatt. We have found that value. So to find the value of isothermal power, we have the expression, that is isothermal power is equal to P1 V dot natural log of P2 by P1. So putting the values, P1 is 1.013 10 raised to power 5, V dot is 0.25, natural log of 25 by 1.013. So simplifying this, we get the value of isothermal power, that is comes equal to 1.353 kilowatt. So now we know about the two powers, that is isothermal power and indicated power. So putting the values in expression number 4, that is 4 expression becomes isothermal efficiency is equal to 1.353 over 2. So simplifying this, we get the value, that is 0.6765. In percentage, isothermal efficiency is 67.65%. So this is the solution of problem 12.3. For more problem solution of power plant, please subscribe my channel. Thank you.